Module 4, Lesson 29, Multi-Step Problems using all the operations. Learning target, I can use substitution to determine whether a given value makes an equation true. I can write and solve equations and inequalities involving real-world problems. More specifically, I can use simplifying expressions, order of operations, and properties of equality to find the solution of multi-step equations. I can use tables to determine answers. I can use substitution to determine if my solution makes the equation true. We are going to spend quite a while working our way through this example. So this is the first step of many. The school librarian, Mr. Marker, knows the library has 1,400 books, but wants to reorganize how the books are displayed on the shelves. Mr. Marker needs to know how many fiction, nonfiction, and resource books are in the library. He knows that the library has 4 times as many fiction books as resource books, and half as many nonfiction books as fiction books. If these are the only types of books in the library, how many of each type of book are in the library? Now, as we look at this situation, there is a lot of information going on here. So we are going to want to break this down, pull out information, and develop a plan of action. So as we look at this, there are a few different pieces of information we probably want to pay attention to. First, we know that the library has 1,400 books. That sounds to me like the total number of books in the library. It sounds to me like we have fiction, nonfiction, and resource books in the library. So I hear that we have 3 types of books and a total number of books. I also see that there are some relationships here. We have 4 times as many fiction as resource and half as many nonfiction as fiction. So thinking about the last lesson, lesson 28, we should be thinking about which is our smallest number of books. What is our building block that we can build up from? So what are the different pieces of information that we have? Well, I just highlighted those, but I'll summarize them here. The library has 1,400 books. It has 4 times as many fiction as resource. It has half as many nonfiction as fiction. Now, how could we represent all of this with a tape diagram? Well, the first thing we could do is we could draw a tape diagram that represents the total number of books in the library. So we're going to draw a nice big long tape because that's the total. So we have a tape for the first piece of information. Now, looking at this next piece of information, what would we draw? Well, we're going to need 2 more tape diagrams. We're going to need one for the fiction books and one for the resource books. Now it says that there are 4 times as many fiction as resource. So do we have more fiction or more resource? Well, if I have 4 times as many fiction as resource, I'm going to have less resource. So I'm going to draw a unit for my resource books. So this is my total up here at the top. This is my resource books. And it says the resource books, the fiction are 4 times as many as them. So I now need to draw a tape that has 4 units the size of the resource books, because these are going to be my fiction books. Oh, now there's one more tape that I need to look at. I need to look at this half as many nonfiction as fiction. Before I look at this last section, I've already got something of an idea about what my building block is. If the nonfiction books are half as many as the fiction, they're going to be this much, which means that my resource books are going to be my building block. So I'm going to use the variable r throughout this problem. I'm going to use the resource books because everything else is bigger than the resource books. Now, if I used the total number of books, or the fiction books or the nonfiction books, then I get to play with fractions. So it's not impossible, but I don't want to go that way. I'm all about let's make this easy. So I'm going to use resource books as my building block. So then I need a tape diagram for my nonfiction books, and I've already said it, my nonfiction books are half of what my fiction books are. So they've got 2 units. The fiction books have 4 units, and the resource books have 1 unit. Now I should at this point be able to say, if these are the 3 types of books in the library, how many units will my total have? If these are the only 3 types of books in the library, I can say that I'll have 1, 2, 3, 4, 5, 6, 7 units in my total. I'll make a little note of that off on the side. We'll come back to that in a little bit. So they're asking how did we decide how many sections the tape diagram would have? Well, it says that the nonfiction books are half of the fiction. So if these 4 units are the fiction, the nonfiction is half of that. And we've looked at that twice now. So now we're going to look and say, how can we represent all of this algebraically? Well, we know that each one of these little units is an R. So we can say that the nonfiction books are 2 of R. And we can say that the fiction books are 4 of R. And we can say that the resource books are R. And it sounds like we're pirates now. So now we're going to use our tape diagrams to help us solve the problem. And I'm going to erase some of what I've got on here, and our tape diagram is going to change a little bit. What I've done on this slide is I've taken all of our 7 units, our resource books, our fiction books, our nonfiction books, and I've combined them together to make a total, which I kind of hinted at over in the corner here when I said the total was going to be equal to 7 units. Now each one of those units is an R. So here's my resource books. Here are my 1, 2, 3, 4. Here are my fiction books. Here are my nonfiction books. But each of the units is an R. So I have my resource books plus my fiction books, and my fiction books can be expressed as 4 of R. And I've got my nonfiction books, which can be expressed as 2 of R. And altogether I have my total number of books, which is equal to 1 R plus 4 R's, which is 5 R's, plus 2 R's, which is 7 R's. And we know that the total is also equal to 1,400 books. So I have 7 R's are equal to 1,400. And at this point, all we need to do is scale down to a single R and find out what each of these little boxes is worth, what the value of each of our units is. So if I scale this down or use my identity properties, I have R times 7 divided by 7, which will leave me R. I really feel like a pirate. And over on the other side I have 1,400, and I'm going to divide it by 7, and I'm going to find that R is equal to 200. Now, what does that mean? Well, R being equal to 200 means that each one of these units has a value of 200. And if each one of them has a value of 200, I can say that the resource books have 200. I can say that the fiction books are 4 of 200, which is 800. And I can say that the nonfiction books are 2 of 200, which is 400. My resource books, my fiction books, and my nonfiction books. All right, so we've already looked at this part. I get going on these slides and forget to advance things. So we've already looked at this one to find the value of R, and we found that R was 200. We've been there. And we're busy interpreting what does this 200 mean. It means there's 200 resource books in the library because R represented the number of resource books. Then we can use that to find the number of fiction books. 4 times R is equal to the fiction books, which is then equal to 800. And the nonfiction books are 2 of R, so they're equal to 400. And we've now caught up with where I'm at. Now the question is, could we use a table to solve this problem? So can we think of this problem in a different way? So if we were to make a table, how many columns would we need? Well, I would need one for the resource books. I would need one for the fiction books. I would need one for the nonfiction books. And I would want a column for the total number of books. So I would need 4 columns. So go ahead and set up a table with 4 columns and label each one of the columns. And we can go back through and we can look at our important information. I know that the total is 1,400 books. I know that I have fiction, nonfiction, and resource. I know the library has 4 times as many fiction as resource. And I know that my nonfiction is half of my fiction. And I know that that represents the total. So in the second row of the table, I would actually think about this algebraically. I could say that I know that the total number of books is 1,400. I've used that piece of information. I can say that my fiction books are 4 times as many as my resource. So I could say that my fiction are 4 times as many as my resource. I could say that my nonfiction is half of my fiction. And if I look at my fiction, I can say that half of my fiction is 2 times my resource books. And then I can say that my resource books are my resource books. Once again, I've still followed kind of the same pattern of identifying what is my smallest building block, and I have used that information to construct my table. Now I'm noticing as I look at my table that I have used R in 3 spots for all 3 types of books. So it may not be useful to say that my nonfiction are now half of my fiction. It's probably better, simpler in my life, if I just say that the nonfiction are double my resource books. So if R equals 1, now we're going to use some substitution here. If my resource books, if I have 1 of them, how many of each type of book would I have in the library? Well, if the resource book is 1, the nonfiction is double 1, 2 times R, which would be 2. And the fiction book would be 4 times R, so 4 times 1, which is 4. And I could actually rewrite this 1,400 and say that it's 7 times R. The total is the 4R plus the 2R plus the R. So if I have 1 resource book, I will have 7 books in the library, 7 times 1. So how could I fill out another row of the table? Well, if I'm trying to get to a total of 1,400 books, I'm going to need to go a little bit bigger here. And I like numbers that are easy to multiply by. So I'm going to say 100 books. If I've got 100 resource books, I multiply that times 2, and I have 200 nonfiction books, and I multiply that times 4 and I have 400 fiction books, and I could multiply that times 7 and say, oh, I have 700 total books. Now I'm starting to feel like I'm getting a little bit closer to that 1400. So filling out another row on the table, we can just keep putting in different values for R. Now in this case they're saying go ahead and put in a 5, and I'm going to skip that part. I already put in 100. Well, you know what? Go ahead, pause. Go ahead and put 5 in your table and see what happens. So I've got a 5, and I'm going to double the 5 and have 10, and I'm going to multiply the 5 times 4 and I'm going to have 20, and I'm going to multiply the 5 times 7 and have 35. Now I can double check this by asking, is this number here, fiction, 4 times this number? Do I take my resource book, multiply it by 4, and get my fiction? Yes, it worked. Are my nonfiction books half of my fiction books? Is nonfiction 1/2 of fiction? 10 is half of 20. Yes. So that was an example there of quickly checking the logic, the thinking of the table, and is it matching? So how could we figure out if we've got 1400 books? Well, I've already taken a step here with 100, and I know that 700 is half of 1400. So I could double what I did on this row. So instead of 100 resource books, I could say I have 200 resource books, which would mean I have 400 nonfiction, which would mean that I have 800 fiction. And I'll have 200 times 7, which is 1400 total. And on this row then, I have my answer for how many of each type of book I would have in the library if I had 200 resource books. All right, and now how can I check? Well, this goes back to the logic. Is the fiction book 4 of the resource books? 200 times 4 is 800. Check. Is, or are, the nonfiction books half of the fiction books? They are. Check. Is my total number of books 1400? It is. Check. So I have checked the 3 requirements that were outlined in the word problem, and everything checks out. I must be in a good spot here. All right, so now there are some exercises, 3 or 4 of them, and you're going to go through the same kind of process here. You're going to think about them algebraically. You are going to create tables to solve these problems. So Indiana Ridge Middle School wanted to add a new school sport. So they surveyed the students to determine which sport is most popular. Students were able to choose among soccer, football, lacrosse, or swimming. Now in my head here I'm keeping track that I'm asking a question that is going to have 4 different answers. So as I'm thinking about my table, I'm thinking I probably want 5 columns because I want to know the total number of students that answered. The same number of students chose lacrosse and swimming. Now I'm going to set some variables here to help me out. So I've got lacrosse as a sport. I've got soccer as a sport. I'll use a C for that. I have football for a sport, and I have swimming for a sport. I'll use a W for that. Now it tells me the same number of students chose lacrosse and swimming. So lacrosse is equal to swimming. So those are going to be the same number. Now that's really useful when I start to create a table or create an algebraic expression. The number of students who chose soccer is double those who chose lacrosse. So soccer is double lacrosse, which means it's also double the swimming. The number of students who chose football was triple the number of students who chose swimming. So football is triple swimming, but that means it's also triple lacrosse. Now, as I start to look at this, I see that L's and W's. Let me fix this here. This last W should be a lacrosse. Looks like my building blocks are going to be either swimming or lacrosse. Oh, it also tells me 434 students were my total. So as I think about this, I'm going to build with either W's or L's. And I guess I'm going to do W's because it's right there. So I'm going to have the number of students that picked lacrosse, which is the same as the number that picked swimming. I have 2 times that many that picked soccer. I have 3 times that many who picked football. And then I have the same number again, obviously, that picked swimming. And all of this together is going to be equal to my total number of students. So if I were to now combine all of my like terms, I've got 1 W here plus 2 W's, that'll give me 3 W's, plus 3 more, which gives me 6 W's, plus 1 more, which is going to give me 7 W's, and that is going to be equal to my total, which is 434. So at this point, I have it all set up as an equation. I have combined my like terms and substituted in the number that I have. So I can now solve this problem by finding 434 divided by 7. And I'm going to find out that W is equal to 62. So swimming and lacrosse are each 62. Soccer is double 62, so 62 times 2, or 62 plus 62, which is 124. And football is triple that amount. So 60 times 3 is 180, plus 6 more is 186. So I have found that I have 62 students who have picked swimming, 62 who have picked lacrosse, 124 who have picked soccer, and 186 who have picked football. Now I can double check my answer doing a couple of things. The first thing I need to do is I need to add all these numbers together and make sure they equal 434. So 62 and 62, which is 124, plus another 124, which is 448, and 448, my goodness, that was about a horrible mistake there. How about 248? And I'm going to take 248 and I'm going to add 186. All right, so the first part of my check has worked out. I have the right total number of students, 434. Now the second part of my check is I need to check the relationships. Is my soccer double my lacrosse and swimming? Yes, it is. Is my football triple my my lacrosse and swimming? And are my swimming and lacrosse equal to each other? Yes, they are. So now I have checked all of the information that was given in the problem. So I've now solved this algebraically. Now if I were to look at this as a table, which is the second part of what we're supposed to be doing here, I decided that I needed 5 columns. And I'm going to need 1 for soccer, 1 for swimming, 1 for lacrosse, and 1 for football, and 1 for a total. Now it says that the lacrosse and swimming are equal to each other, and I have already figured out that they are the lowest numbers because everything else is a multiple. Lacrosse and swimming are equal. Soccer is double lacrosse. And football is triple swimming. So my building blocks are going to be lacrosse or swimming. So I'm just going to, in this time, instead of using swimming, I'll use lacrosse. So swimming is equal to lacrosse, so it will be lacrosse. And lacrosse will be lacrosse. Soccer is double those who chose lacrosse, so double the lacrosse. I've already decided that the swimming is equal to the lacrosse, and so I can triple that to get the football. I can combine all my like terms, 2 plus 1 plus 1 plus 3, and have 7 of the lacrosse. So if I have one person who picks lacrosse, I have one person who picks swimming, I have 2 that pick soccer, and I have 3 who pick football, and I have 7 times 1, which is a total of 7 students. Now I am trying to get up to 434 here. As I look at this, if I drop in 100, it's going to be just a little bit too big. If I put in 100 people picked lacrosse, that's 100 people who picked swimming, that's 200 who picked soccer, and that's 300 who picked football, and that's 700 total students. That's not going to work because only 434 students answered this survey. So I need to use a number smaller than 100. So I could go half. I could do 50. So here's 50 and 50, and then I'm going to double that and have 100, and I'm going to triple that and have 300, and then I've got 7 times 50, which is 350, and I'm looking and saying I'm a little bit closer. I'm getting there, but I need to be a little bit bigger. I don't have quite enough. I'm about, have I added this together right? 3, no, of course I didn't. I did something wrong here. Right here. Here's my mistake. My brain was screaming at me, this is not right. Okay, 3 times 50 would be 150. Okay. So 150, okay, good. So now I've got a total of 350. Oh, wow, that works looks way better. Okay, so here I've got not enough people. I'm still 144 short. So I got to stop and think about this here. How can I make this a little bit bigger? Well, I could try 5 more. I could do 55. And I could double that to have 110. And I could triple that, so 55 times 3, which gives me 165. And I could say that I've got 7 of 55. Well, that gets me a little closer. I mean, that's 385, but I'm still not there. So I could, what if I did, and I'm going to run off the board here, but I could say, what if I did 60? And let's see here. See if I can buy myself some space without having to erase everything that I've done. So what if I tried 60 in here? So 60 and 60, and double 60 is 120, and triple 60, which is 180, and 7 times 60, which is 420, and I'm looking and saying, wow, that's super close to 434. So I just need to add just a little bit more. Now I already know that if I have one person, that's worth a total of 7. If I have one that picks lacrosse, that gets me 7 people. And I can see that I'm 14 away here, so I'm going to try adding 2 on here. Let me get rid of some of these. So I'm going to add 2 and do 62, 62, double that, 124, triple that, 186, 62 times 7 is 434. So now on this row, I have thought my way through and found how many I would have playing each of the sports. Now I know compared to doing this algebraically that tables just seem to take a whole lot longer. They do. They really do. However, there's some great mathematical thinking and some number sense involved with tables. So I know that it takes a little while, but don't let that keep you from a great learning experience. All right, exercise 2. Going to be doing the same thing here. I'm probably just going to do this, well, we'll see how it goes. At Prairie Elementary School, students are asked to pick their lunch ahead of time so the kitchen staff will know what to prepare. On Monday, 6 times as many students chose hamburgers as chose salads. All right, I just heard a comparison here. Hamburgers and salads. 6 times as many chose, so my hamburgers are going to be greater than my number of salads. Matter of fact, it's going to be 6 times as much. So I've got hamburgers, I've got salads. The hamburgers are 6 times the salads. Okay. The number of students who chose lasagna is 1/3 of those who chose hamburgers. So lasagna is 1/3 of the hamburgers. Now it says here that there are a total of 225 students. And if hamburger, salad, and lasagna are the only 3 options, how many students ordered each of the lunch choices? Well, I've got the salads here. I know the hamburgers are 6 of the salads, and I know that the lasagna is 1/3 of the hamburgers. So can I look at this 6 of the salads and find 1/3 of that to be the lasagnas? Well, 1/3 of 6 is 2. So 2 salads. So my algebraic equation here is I'm going to have the salads plus the hamburgers plus the lasagnas, and they're going to be the total. But I'm going to substitute and replace. The salads plus 6 of the salads, because that's what we figured out the hamburgers are, plus the lasagna, which we figured out is 2 of the salads, and that is going to be altogether our total. So altogether I've got 1 plus 6 plus 2, which is going to give me 9 of the salads is equal to the total, or 9 of the salads is equal to 225. Now if I scale this down and find out what 1 salad is, then I can figure out the hamburgers and lasagnas. So scale down, divide by 9 here, divide by 9, so I have a single salad. 225 divided by 9, 9 times 2 is 18. 45, 25. So the number of salads is 45. 6 times the number of salads is 270 for the hamburgers. And then double the salads, 45 times 2 is 90 for the lasagna. So I'm going to say there are 270 students that ordered hamburgers, 45 that ordered salads, and 90 that ordered lasagna. Now, double checking my work here. I've got 270 plus 45 plus 90. 11 and 9 is 20. Uh-oh, something's not right here. I added it together and it didn't equal 225. I've messed up. So the question is, what did I do wrong? So I need to go back and I need to look at my work here. Let's see, so I've got the salads plus 6 times the salads are the hamburgers plus 2 times the salads is the lasagna. I'm going to double check those here. It says 6 times as many chose hamburgers as salads. The number of students who chose lasagna is 1/3 of hamburgers. Okay, so double the salads. Okay, so I've got 9 of my S's, which equals 225. So 225 divided by 9. 2 times 9 is 18. So 25. Oh, wow, what a silly mistake. And of course, hopefully you were watching this video thinking, no, you wrote down the wrong number. This 45 right here should be a 25, which is going to change these other numbers. 6 times 25 is 150, and 2 times 25 is 50. And now if I add everything together, I've got 150 plus 25 plus 50, and I have a total of 225 students. My hamburgers are 6 times my salads, and my lasagnas are 1/3 of the hamburgers. I'm going to skip the table on this one, but if you want to try out the table, go right ahead. Good thinking activity. All right, here we go. Exercise 3. On this one, I'm going to try out the table. The art teacher, Mr. Gonzalez, is preparing for a project. In order for students to have the correct supplies, Mr. Gonzalez needs 10 times more markers than pieces of construction paper. All right, I hear I've got markers. I hear that I've got construction paper. And I hear that the markers are 10 times the construction paper. So 10 of the paper. And actually, I said I was going to do a table here. So let me set it up as a table. All right, so I've got markers and construction paper. I've got the paper, and the markers are 10 times the paper. Okay. He needs the same number of bottles of glue as pieces of construction paper. So I've got the glue, which is going to be equal to the paper. Okay. The number of scissors is half the number of pieces of construction paper. Ooh. All right, so scissors are half of the paper. Oop. Let me try writing that as a half. Half of the paper. And I've got a total here that is going to be 400. Well, I noticed that I was thinking that the paper was the smallest unit, but in reality it was the scissors. So I'm going to come back here and say that I've got the scissors, and the glue is double the scissors, and the paper is double the scissors, and I need to multiply this paper times 10 to get the markers. So that's 20 of the scissors. And altogether I've got 20 plus 2 is 22, plus 2 more is 24, plus 1 more is 25. I've got 25 of the scissors is my total. And I'm trying to get to 400. So let's see here. Well, I know, and this is where some number sense comes in, I know that if I take 25 and multiply it times 4, that I'm going to get 100. So how can I use that in this problem? If I say that there's 100 scissors, I know that it's going to get way, 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 way too big. But what if I just put in 4 of the scissors? So 4, 8, 8, and 20 times 4 is 80. So 80 plus 16 is 96, plus 4 is 100. Now if I multiply that times 4, I will get 400. So I'm going to do 16, and then I'm going to multiply that times 2 and get 32, and multiply that times 2 and get 32, and multiply 32 times 10 and get 320. And if I add these together, 320 plus 64 plus 16. I get a total of 400 items. And I can see that I've got 320 markers, 32 paper, 32 glue, and 16 of the scissors. Now I need to check and make sure that this matches the correct criteria in the problem. Do I have 10 times more markers than construction paper? Well, paper times 10 is 320. Do I have the same number of glue as paper? Well, the glue and paper do equal each other. Are the scissors half the paper? 16 is half of 32. Yep. And my total is 400, so I have met all of the criteria for this problem. All right, looking at the last exercise here, and I'll use algebraically on this one. The math teacher, Ms. Zentz, is buying appropriate math tools to use throughout the year. She is planning on buying twice as many rulers as protractors. So I have rulers, I have protractors. I hear that the rulers are double the protractors. The number of calculators Ms. Zentz is planning on buying is 1/4 of the protractors. So calculators are 1/4 of the protractors, which means that the protractors are 4 times the calculators, which means that the rulers are 8 times the calculators, because I have to double the protractors to get the rulers. If Ms. Zentz buys 65 items, how many protractors does Ms. Zentz buy? Well, I've got 8 calculators, which is the rulers, plus 4 calculators, which is the protractors, plus the calculators, and altogether this is going to total 65 items. 8 and 4 is 12, plus 1 more, which will give me 13 of the calculators are equal to 65. So if I scale this down to 1 calculator by dividing by 13, I'll find that the calculators are equal to 5. I've got 5 calculators, and if I multiply that times 4, I have 20 protractors. If I multiply that times 8, I have 40 of the rulers. Quick check here, does this total 65? 40 plus 20 plus 5 is 65. All right, my total is good. Do I have 1/4 as many calculators as the protractors? 5 is 1/4 of 20. Do I have double the number of rulers that I have of protractors? 40 is double 20. So yes, I'm good to go. Now the answer to the question is, how many protractors does Mrs. Zentz need to buy? Ms. Zentz needs to buy 20 protractors. All right, so Pam says she only needed 2 rows in her table to solve each of the problems. Now, how was she able to do this? Well, Pam only needed 2 rows on her table because she found the scale factor from the total in the first row and the total given in the problem. And once this scale factor is determined, it can be used for all the columns in the table because each table is a ratio table. So in other words, she was able to look at it using her ratio reasoning and figure out what's going on. So she could take her smallest unit and say, what do I have to do to get up to my total? And she put that to work. So is there a more efficient way to get to the answer than choosing random values by which to multiply each row? And I know it was really annoying to watch me sit there and do guess and check on those tables. Yeah, there are more efficient ways, and this gets back to the ratio relationships and the scaling. Find out how many groups of one set of materials it will take to obtain the total amount desired, and then multiply the entire row by this number. Alright, so looking at the I can statements, I can use simplifying expressions, order of operations, and properties of equality to find the solution of multi-step equations. I can use tables to determine answers, and this is something that you may want to go back and explore some more. I can use substitution to determine if my solution makes the equations true. All right, looking at the learning targets, we used substitution, so we substituted values into an equation, and we solved real-life problems by writing equation. So I know that this lesson is a little bit longer, but there's a lot of good stuff there. This is the conclusion to Module 4, Lesson 29. Make sure you finish your problem set. Make sure you take your exit ticket. If you've got questions, make sure you reach out to your teacher.